We continue with trigonometry, and today I want us to have a look at the trigonometric ratios. This is just another way of talking about the sine, the tangent, as well as the cosine of functions. For example, when we talk about tan theta and we say it is equal to 2 over 5, you realize that this one, 2 over 5, is already a ratio. And we say that every angle will always have a ratio like this one. These ratios are derivable. And today, let us try to look at the ratios of the basic angles. These are the angles like 30 degrees, 60 degrees, 90 degrees, 45 degrees, even 0 degrees. We start with the ones for 30 and 60. Let us consider some equilateral triangle like this one. I hope this one is able to be equilateral enough. If it is equilateral, then it means that each of its angles here is actually equal to 60 degrees. And if this triangle had 2 units, just for purposes of finding it easier to deal with the divisions, we can see that a perpendicular bisector of its base will have to touch this point here like this. A perpendicular bisector, it would create a height h, and most importantly, it will divide this angle, which originally is 60, into 2 angles of 30 degrees. I hope they are easy to see. Because this line H was perpendicular bisector, we also realize that he divides this line into 2 equal parts to have 1 unit and 1 here, so that 1 plus 1 creates a 2. And as we speak now, we are able to see that we can find h using the Pythagoras theorem. How we can say that h squared plus 1 squared is actually equal to 2 squared. H squared would be equal to 4 minus 1, which would be equal to 3h squared. When we take the roots, we see that h is actually equal to root 3. It would be plus or minus, but because we are talking about lengths, then we have to be positive. The implication therefore is that we have a new right angled triangle which looks like this: 30 degrees here, 6 degrees, and it is right angled. If this is true, then we also see that this one here is root 3, and now this is 2 and this is 1. From this, we can take the ratios of 30 degrees and 60 degrees using SOHCAHTOA. What will it be? From SOHCAHTOA, you would easily see now that the opposite to 30 is 1. And you can say that the sine of 30 is equal to 1 over the hypotenuse, which is 2. The adjacent of 30 is actually root 3, and therefore it is adjacent over the hypotenuse, which is 2. Also, the tangent of 30 can see that it is equal to opposite, its opposite is 1 over the adjacent, which is root 3. And these are the trigonometric ratios for the angle 30. We can also see that the sine of 60, if you look at sine 60, the opposite to the sine of 60 is root 3 over the hypotenuse, which is 2. The cosine of 60 then becomes adjacent, which is 1 over 2, and the tangent of 60 becomes root 3 over 1, which is actually equal to root 3. Those are the trigonometric ratios for the angle 30 and the angle 60. For angle 45 degrees, let us try to derive this one using a unity square. This unity square, of course, it is known that the angle here is 90. Angles there are 90, and if we draw some diagonal, because it is a unity square, then we are meaning that the sides are equal to 1. Being a unity square, the implication is that the sides are equal to 1 unit. Then this angle here should become 45, since a square has got all its angles equal to 9. A line bisect, or this diagonal here would bisect that angle into 2 equal angles. The implication is that the diagonal here, which now looks like the hypotenuse, we can still get it from the Pythagoras theorem and state that the hyp squared is actually equal to 1 squared plus 1 squared, which is equal to 2. Hypotenuse therefore becomes root 2. So we can say now that this is root 2. We realize then that if we want to get the sine of 45, is equal to opposite. The opposite of 45 is that. So equal to opposite of hypotenuse, which is √2. The cosine of 45 will be equal to adjacent, which is this one here, over hypotenuse, which is √2. So it will be equal to 1 over √2. The tangent would be equal to opposite over adjacent, which is 1 over 1, which is equal to 1. So these are the ratios for this angle, the trigonometric ratios for this angle 45. Now for angle 0 degrees, let's not forget our right angled triangle, like this one. You would realize that if this is some angle theta, one way you can make this angle become 0 is to move this hypotenuse clockwise. As you move this angle clockwise, theta reduces and it tends towards 0. It will move like this towards 0. But the most important thing is that as this theta moves towards 0 degrees, as it moves towards 0 degrees, the opposite, this opposite height here, the opposite of theta, goes on reducing. It goes on reducing towards 0. It goes on reducing, or we say opposite also tends to 0. And because the opposite is tending to 0, then the functions which rely on it, like opposite over hypotenuse and opposite over adjacent, automatically tend to 0 by that fact, because this is 0, this one is also 0. Therefore, opposite over hypotenuse, which is sine 0, becomes 0, and tan 0 also becomes 0. But also, as theta tends to 0, it tends towards 0, you realize that the hypotenuse tends to adjacent. You realize that the hypotenuse almost becomes the adjacent, so much that adjacent over hypotenuse actually tends to 1. Hence cos 0 is equal to 1. For 90 degrees, you realize that as the theta tends to 90 degrees, the opposite tends to hypotenuse, or moves towards the hypotenuse, and the adjacent moves towards 0. So much that opposite over hypotenuse will tend to 1. Hence, sine 90 is equal to 1. And adjacent over hypotenuse tends to 0, so much that cos 90 is equal to 0. Also, as adjacent moves towards 0, you realize that the opposite over the adjacent tends to infinity. It is almost undefined. You don't get the meaning, because adjacent becomes 0. Hence, the tangent of 90 is infinite, like that. Meaning, this symbol here meaning undefined. It means that we don't have the value of the tangent function when the angle is 90 degrees. It is from these ratios above that trigonometric ratio tables are drawn, and you can read answers just straight from there. For example, from what you have just seen here, if you have an angle here and you have 0 degrees, we have 30 degrees, we have 45 degrees, we have 60 degrees, and we have 90 degrees, and we have let us try to look at the sine, the cos, and the tangent. You would realize that the sine of 0, as you have seen, it is 0. You can just come and read from it. We also saw that the sine of 30 was a half, and we saw that the sine of 45 was 1 over root 2. We also found that the sine of this was root 3 over 2, and the sine of 90 was 1. We saw that the cosine of 90, we found it to be 1. We also found this one to be the cosine of 30. We found it to be root 3 over 2. And the cosine of 45, we found it to be 1 over root 2. And we found the cosine of 60 to be a half, but the cosine of 90 was found to be 0. We also found to be the tangent of 0 to be 0. We have found the tangent of 30 to be 1 over root 3, and then that of 45 to be 1, that of 60 to be root 3, and the one of 90 to be undefined. This one is, we call this one a trigonometric ratios table. You can just come and you read from this. It can be expanded, and actually there is a trigonometric table book from which you can get these values, keep getting these values one by one, the way you would have wished or your need may be. For now, we can stop here. Next time we meet, we shall talk about the sine and the cosine rules. See you.